So today we are going to start a new chapter and we're going to talk about how we describe motion and what motion actually is. So I'm going to make myself small in the corner. All right, I'll be over here small in the corner and your PowerPoint is right here in the middle of the screen. Maybe, maybe not. Let's see if I can. There we go. All right, so to describe motion, so you look out a window and you see a mail truck and it stopped next to a mailbox, and that's in the picture right here. So mail truck, mailbox. A minute later, you look out your window again and the mail truck is farther down the street. You didn't see the truck move. You have no way of knowing that the truck has a motor in it and that it can move. But you used a reference point. You used your mailbox. And so there was something there was something behind your mailbox, and that something moved. It's not there anymore. So we can infer, based off the reference point, that the mailbox has the ability to move. Or not the mailbox, the mail truck has the ability to move. It has tires, it has wheels, might even have a motor. We don't know how it moved. We didn't see that. But we know it moved. So in science, we use a reference point to determine if something moved. You look up and you notice the cup is next to you by your plate. You start eating or you look away, you look back up again, and there's no cup next to your plate. Your plate was your reference point. You compared everything around to your plate. That cup's not there anymore, so you know it somehow had to move. So the definition of motion is when an object changes position relative to a reference point. That reference point can change. That reference point can change between two people. I could look at this picture of the skateboarder, and I could use the stairs as a reference point. You might look at this picture of a skateboarder, and you might use this sign back here as a reference point. That's completely fine. If the object is actually in motion, it will change relative to both of those reference points. When we get into higher math and distances and displacements, that's really going to matter. Right now, you just need to know that you use a reference point to determine whether something's moved or not. And there's two different things we can determine when something has moved. We can determine distance, or how far total you've traveled. And we can determine displacement. Displacement is the distance and direction of your change in position from the starting point. So your car's odometer gives you distance. It tells you how far your car has gone. Your car has 100,000 miles on it. But if you were to drive your car back to the factory where it was built, its displacement would be 0 because it's back where it started. It's back at that exact same factory it started at. Its distance is hundreds of thousands of miles usually before you get rid of a car. So they're two separate things. So you can have distance, but not have displacement. You can also have a displacement that's equal to your distance. You drove 4 miles to the grocery store, so that's your distance. You went 4 miles. Your displacement is 4 miles because that's where you ended. You didn't go anywhere after that. You ended at the grocery store. So when we look at distance, our SI unit is going to be a meter. Longer distances are going to be measured in kilometers. We're going to go back to that base 10 unit thing. So King Henry died by drinking chocolate milk. We can tell here that 1 kilometer is equal to 1,000 meters. So we're going to say that a football player is on the 50-yard line. And he is going to not drop back in the pocket. We're pretending. So he's just going to throw the ball from the 50-yard line, and the ball goes all the way down to the 10-yard line. At the 10-yard line, it's intercepted by the other team, and the other team runs it back for 20 yards before they're tackled. So the total distance, that says meters, that should be yards, would be, we're going to start from where the ball started. So we went 10, 20, 30, 40. Then the ball traveled back this way, 50, 60 yards. Obviously, we don't measure in yards in science, but I'm using a football field, and we measure football fields in yards in America. Not in Canada, though. Displacement. How far is the ball from where it started? So the ball started on the 50-yard line. The ball ended on the 30-yard line. So the displacement is 20 meters or 20 yards to the east. It ended up 20 yards to the east of where it started. Even though it traveled 60 yards, it only ended up 20 yards east. So speed is the distance an object travels per unit time, or the rate of change in position. So our formula for speed is our average speed equals our total distance divided by our total time. So when we abbreviate speed, we're going to use the letter V. So V equals D divided by T. There's 3 types of speed. There's instantaneous speed, average speed, and constant speed. Constant speed is speed that doesn't vary. Constant speed is not really attainable. Most things don't have constant speed. The only way you're going to get constant speed is if you put a car in cruise control or you have a constant speed vehicle. They're little vehicles we use for science that are meant to go a constant speed at a constant rate. That's speed that doesn't vary. So if I were to say you went 1 mile down the road and it took you 1 hour, you're going awfully slow, but it took you 1 hour. You went 1 mile per hour. Do you think you walked 1 mile per hour that whole way? Probably not, right? If it took you an hour to get a mile down the road, you probably stopped and talked to your friends. You might have ran for a little bit. You might have sat for a little bit. You might have walked for a little bit. So that 1 mile per hour is an average speed. It took you 1 hour to get that 1 mile. So on average, the total trip took you at 1 mile per hour. So that's where our speed formula comes from. And whenever we use our speed formula, we're calculating average speed. We're not calculating instantaneous speed. Instantaneous speed is speed at that very given moment. If you look down at your speedometer, it gives you your instantaneous speed. How fast are you going at that moment? If a cop has a radar gun and they use their radar gun and they say you were going 60 in a 30, ma'am, that's my instantaneous speed. It's not my average speed. So when we use the formula, we get average speed. So I don't know. You could have gone, if you went 60 miles in 1 hour, you could have gone 75 miles an hour for part of the trip, and then 2 miles per hour for part of the trip, and then 100 miles per hour for part of the trip, and it averaged out to that 60. That's our average. Constant is if for that entire trip you traveled at 60 miles per hour. Your mom got on the road, put the cruise control on, and didn't touch the gas at all, ever, or the brakes. Probably not the best idea. This is why automated cars took so long to come up with. So, average speed and constant speed are kind of constraints put on science that we use in the lab. Instantaneous speed is what's really going on. So here's our formula. We have speed equals distance over time. And this is a speed triangle. And I'm going to get a little, I'm going to move this over and get a shape to show you how to use this speed triangle really quick. So I'm going to insert, and I just want to grab any shape. It doesn't really matter. We'll use a blue square. Maybe. Yes, we'll use a blue square. All right, so if I want to find out distance, I am going to take this blue square and I'm going to cover up distance. And distance is equal to speed times time. Let's see. Let me make it big again. I need to just enter line. So distance is equal to speed times time. And that did not show up at all. It's blue, apparently. All right. If we wanted to find out speed, we're going to cover up the S. So speed is equal to distance divided by time. If we want to find time, we're going to cover up the T. And time is equal to distance divided by speed. So instead of having to come up with those formulas each time and think about plugging in the numbers and doing more math, it makes it a lot easier for us if we can just remember this triangle, and then we can just cover up what we're looking for, and it's simple multiplication or division, and we're not getting into algebraic equations. So let's look at some examples. A passenger elevator traveled from the first floor to the 60th floor, a distance of 210 meters in 35 seconds. What is the elevator's speed? So speed is equal to distance over time. So I'm going to put speed is equal to 210 meters over 35 seconds. My units are different, so they can't cancel out. When I do the division, I will get 6.0 meters per second. All right, let's look at another one. A motorcycle is moving at a constant speed of 40 kilometers per hour. How long does it take the motorcycle to travel a distance of 10 kilometers? So it tells us that the speed is 40 kilometers per hour. That's in the wrong box. It tells us the distance is 10 kilometers. So I'm going to cover up my time. So my formula is distance divided by speed. My distance is 10 kilometers. My speed is 40 kilometers per hour. I'm going to do the math. My kilometer units cancel out. They're the same on the top and the bottom. I'm left with hours. So my time is 0.25 hours. Roughly 30 minutes. All right, let's look at one more. How far does a car travel in 3/4 of an hour if it's moving at a constant speed of 88 kilometers per hour? So we want to know how far. So how far is usually distance, right? How far do we have to go? How far is it? So we know the time that it gave us was 0.75 hours. So I'm going to plug that in. We know the speed is 88 kilometers per hour. So I'm going to plug that in. So distance is equal to speed times time. My distance was 88 kilometers per hour. My time was 0.75 hours. My units of time are going to cancel, and I'm going to be left with 66 kilometers. That is all I have when it comes to position time graphs. The next slide, or the next lecture, is going to be on graphing motion. If you have any questions or comments, feel free to email me or ask for a Zoom time, anything like that. I'm available.